This video is on the distance and midpoint formulas that are covered in section 1.1. So our learning for objectives for today are to use the distance formula and the midpoint formula. Please note that I have the formulas listed below, the distance formula and the midpoint formula. We're going to work each of the examples below so you have an idea of how to use these formulas. The first one we're going to look at is number 1. Please bear with me a second to get to the right page. So please note that I've put the distance formula up here. I'll make it a little bigger. And we also have our question. So what we need to do, put this above, put this below, okay? So we're going to look at our first question, and I'm going to write in pink. And we are going to obviously need 2 points here because if anytime we're going to find the distance, we need 1 point and 2 points to find the distance between them. So, for example, this is point 1. So we know that every point has an x1 value and a y1 value, and this one has an x2 value and a y2 value because it's the second point. Well, now that we have these x and y values, we're going to go ahead and solve our equation. So we have equal to, and we have x2, which is 4, minus x1, which is negative 3, squared, plus y2, which is 10, minus 7 squared. So now we're going to go ahead and simplify. So we have 4 minus negative 3, which is the same as adding. So we have 4 plus 3, which is 7, squared. And we have 10 minus 7, which is 3 squared. So now we have 7 squared, which is 49, and 3 squared, which is 9, which gives me a grand total of 58. Now, please notice this is my answer. When you show your work for your written assignments, your work should look like my work. Notice that everything is nice and lined up, and the final answer is boxed. Now we're going to go to the second problem that we looked at. The second problem says, determine whether the triangle formed by the points A, B, and C is a right triangle. Well, the first thing we need to do is we need to graph it. So we're going to graph our points. So point A is negative 2, so we're always going to do the x-axis first, followed by the y-axis. Please make a special note that the point 0, 0 is the origin. So first thing we're going to find is negative 2. So we're going to go negative 2 in the x direction and then 2 up. Then we're going to go find B, and that's 2 in the x direction and down 1. And then we're going to do C, which is 5 in the x direction and 4 up in the y direction. So now we have some points. So I'm going to go ahead and erase this point here. We don't need that guy. And we're going to make some lines. Find my line tool here. Let's see. Sorry, having some issues. Line tool. So we're going to we need a full line. So we're going to go from here to here. And it's not supposed to be dashed. Try again. Solid line. Alright, so again, we wanted from here to here, and from here to here, and again from here to here. And we're hoping that this is a right triangle, and if it were a right triangle, we would think that the right triangle would be right here. So we can go ahead and label this. So we know this was A, we know this was B, and this was C. So we have to think a little bit more about right triangles. So we can use the Pythagorean theorem. And the Pythagorean theorem tells us that A squared plus B squared must equal C squared. And A, B, and C are the sides of the triangles. So if that's the case, then I need to find the length of each side. So to do that, we're simply going to find the length AB. So we need to find distance AB. And distance AB is going to be the square root. And remember, we're using these two values, so we're going to do x2, so 2 minus negative 2, 2 minus negative 2 squared, plus, and then negative 1 minus 2 squared. So we're going to go ahead and simplify. So 2 minus negative 2 is the same as adding, so I have 4 squared. Negative 1 minus 2 is 3, so plus. Notice that my negative 3 is in parentheses. Okay. And now we're going to simplify again. So now we have 16 plus 9, and that gives me the square root of 25, which we know is 5. So we're going to label that on our graph. We know that AB is 5 units. The next one we're going to do, I'll do in a different color, we're going to do BC. So we have the distance between B and C. So we have the square root. And then we're going to do B and C's x's first. So 5 minus 2 squared plus 4 minus negative 1. So again, we're going to simplify. 5 minus 2 is 3 squared. 4 minus negative 1 is 5 squared. So now we have 9 plus 25, which gives me 34. And the last one, we'll change to one more different color. We're now going to find the distance between A and C. And we should probably go ahead and label this one. This is the square root of 34. And so when we find A and C, we're going to do 5 minus negative 2 squared plus, oops, I have extra parentheses, 4 minus 2 squared. So now we have 5 minus negative 2, so that's 7 squared plus 2 squared. So we have 49 plus 4. So we have the square root of 53. So we're going to go ahead and label that as well. So now we've drawn our triangle, we've found all three sides. The last thing we want to do is see if it's actually a right triangle. So we're going to test it by sticking it in our Pythagorean theorem. So we have a squared, so that's 5 squared, plus b squared, so that's this one, which is the square root of 34 squared. Please remember that a and b are the legs and that c is the hypotenuse. And lastly, we have the square root of 53 squared. So we're going to go ahead and simplify. 5 squared is 25. 34, notice that the square root and the square cancel, so we just have 34. And again, the square root and the square cancel, and we have 53. So now we have 59 equals 53. That is not true, so the answer to this problem is no. And we have one more problem we're going to work, and that's this one. It says find the midpoint. Find the midpoint of the line segment that joins the 2 points. Well, first it kind of helps to know what a midpoint is. So a midpoint means that we have 2 points, point 1 and point 2, and between the 2 points we have a line. Halfway between those lines is our midpoint, and this is M. So since it's halfway, that's exactly how you need to think of these. we're going to find the halfway point of the x's here, and then the halfway point of the y's. So we're simply going to use what they've given us. So for x1 and x2, we have 6 and 4. So 6 plus 4 over 2. And for the y's, we have negative 3 and 2. 3 plus 2 over 2. So we get 6 plus 4, which is 10, divided by 2 is 5. And negative 3 plus 1 is negative 1 over 2, gives me negative a half. So my midpoint is negative 1.